Okay, so I think we already reached a reasonable number, so we can start. Hello, everyone. I am Monica Fernandes from EDP New. EDP New is the Research and Development Center of EDP, and we have been organizing these events that we call R&D sessions. And they are basically webinars where we focus on topics on the energy sector, and normally are topics that are related with projects that we work on. And we started last year doing these webinars, and for example, this year we already explored different topics like blockchain, renewable energy communities, smart buildings. The last one was related with offshore green hydrogen production from wind energy. And for this last session of the year, we decided to focus on a topic that we haven't talked before, which is virtual power plants and how we can use them to unlock flexibility. And in case you didn't have the chance to watch these webinars live, you can go to our website, which is this link. I will send the link through the chat. If you want, you can watch them because the recordings are there. So feel free. There are several topics. There are several interesting topics to look at. But for today's session, as I said, we are focusing on the virtual power plants. And as usual, we'll have the first part for presentations of this topic, and then the second part dedicated to questions and answers, which I encourage all of you to ask the questions you want and to our guests. And you have two options. You can either write them on the chat, or you can raise your hand, and then we'll give you permission to turn on your camera and your microphone to ask the question to our guests. So I encourage you to for you to be involved in this webinar with us and to share opinions and also to discuss some things related to virtual power plants. Without further ado, and I don't want to occupy more time, I will pass the screen to my colleague Miguel Marques, which will be the moderator of this session. And I wish you all a great session. Thank you.
Thank you very much, Monica. Thank you everybody for attending this session. Very happy to be talking to you about the concept of virtual power plants within the scope of project EU-SysFlex. So this is the scope of today's session. We'll be talking about the concept that we've developed and that we've tested within the scope of this project, EU-SysFlex. I will start by giving a short presentation on the key facts of project EU-SysFlex, what it is, where it is, how it works, and our main highlights. And then we'll start focusing on the Portuguese demos, going to the specifics. And then with it, one of them is the virtual power plant demonstration. And I'll give the word straight to Michael Wenzel from Siemens Energy. He will explain the concept of the virtual power plant that we've developed. And then we'll go straight to the roundtable and for Q&A from the audience, where we'll have two guests both from EDP, along with myself and Michael. We will have Miguel Paterna from EDP Produção and Bert Martins from UNS. Now, I'm going to start straight away, but feel free to pose the questions throughout the session in the chat, as Monica was saying. There'll be space for those questions right after our presentations and after our roundtable. Okay, so Project EU-SysFlex is about the demonstration of system integration with smart transmission grid and storage technologies with increasing shares of renewables. As I said, I'll give you an overview of the project, and I'll start by giving you, the key fact of what it is. EU-SysFlex is a very large research and innovation project. This is funded by the European Commission under the scope of program Horizon 2020. These are some of the facts and figures of the project. So the first thing you need to know is that project is about to end. It's about 3 months from its conclusion. Actually, it has experienced a small extension because it was due to end in October this year, but due to COVID, it was extended to February 2022. And there's a typo there in my slide. Sorry for that. But it means this is a 4 year long project, 4 years and 4 months project, with a total budget of 26 million euros and about 20 million of which coming from Horizon 2020, from the European Commission. This is a consortium, a very large one of 34 organizations. We'll get to some more detail ahead, organized in the 12 work packages, quite extent, with 7 demonstrations, which I will also mention, and with a total of close to 100 deliverables. So a lot of work has already been done. As I said, we're in the final stretch of the project. So as you will see, we've already developed quite a lot of work. By the way, I invite you to check it out, because my 10-minute intervention will be too short to show you all the great things that are being done in EU-SysFlex. This project is carried out by a very extensive group of organizations organized in a consortium, very extensive and very wide and in the scope and in the type of organization we were able to assemble. So we have TSOs. By the way, the coordination is by a TSO, Air Grid from Ireland, under the technical coordination of EDF from France. We also have DSOs, distribution system operators, aggregators, technology providers, consultants, also universities. This picture you see on the right is a picture from back in 2018 when we held our second General Assembly here in Lisbon. One of the less physical meetings we all had. Okay, so project EU-SysFlex. The objective of it is to demonstrate reliable and efficient flexibility solutions to reach energy transition targets in EU policies, meaning integrate above more than 50% of renewables in EU's power mix by 2030 and beyond, of course. We've started by looking at the project at the system as a whole and understanding where it is and where we want it to be and how it's changing. We are developing these solutions because indeed the system is changing a lot. The mix is changing to renewables, very obviously. In an effort to decarbonize the whole system. There's a change in demand side as well. There's obviously electrification of heating and cooling. There's also electrical mobility that we have to consider, and there's also the effort to integrate ever larger storage solutions. At the same time, the structure of the system is changing. It used to be a very centralized type of system, as we all know, and it's moving to a more decentralized, where we have many and small sources along the system. So this obviously means there's a shift going on, and I think it's relevant that we look at what we've developed and how the project EU-SysFlex looks at these issues. Very early on in the project, we defined scenarios for the integration of renewables, for the penetration of renewables. And there's 2 key scenarios here. One is the energy transition scenario, in which by 2030, we will have 52% of RES, of renewable energy sources, in the mix. And another one, which is renewable ambition, which means that we will have 2/3 of electricity coming from renewables by 2030. Specifically within those percentages, there's the topic of variable renewables, which obviously is a whole different type of renewables. In the sense that, for the energy transition, we've considered 23% of variable renewables. This means mostly, no hydro. We're talking about specifically wind and solar PV. And for renewable ambition scenario, we're talking about 34% of variable renewables. These are the 2 core scenarios. The change and the difference between these is that the system will need to change because of such high levels of renewables and not variable renewables as well. The main thing is that these are non-synchronous sources. So they're connected to the system via power electronics, which is inherently different to conventional generation as it is. And so, the share of non-synchronous penetration, the so-called SNSP, is a relevant number for us to look at and will become definitely a very important measure of the system. It already is. And we look at the figures we have here on the right of the penetration of this, according to our scenarios, minimum, mean, and maximum SNSP. And we're looking at in some countries like Spain, neighboring Spain, we have the mean scenario, about 73% of SNSP. And in some cases, not reflected here in this picture, we have instantaneously at some moments in time in some countries close to 90% and above, close to 100%. So this means that, I mean, we definitely understood, and if you look at the scenarios we've drafted, there are technical challenges that will arise once we have the system operation at very high levels of SNSP. And so the overall project has been steered towards addressing these issues that are, just around the corner. Really, 2030 will come, sooner rather than later. And so the overall flow of the project that I want you to look at is, how we've thought of these issues. First, understanding that there's a need for change if we are to reach in a very reliable and robust, maintaining the reliability and robustness of the system. If we want to reach targets of above 50% of renewables, understanding that the system is changing, so there's a need for us to change, need for us to change with the system, and there are scarcities that are coming along. There's extensive work done elsewhere in the project, in which we've highlighted the scarcities that will arise in different geographies in Europe. And we understand that obviously future system needs that we need to address. And that's, the components that we put together to address these challenges and these system needs are very various, are various and are wide in scope. This will all lead to, the project's end game is really this flexibility roadmap, in which we're going to list all in a very comprehensive manner, how the system as a whole can achieve these figures. What challenges will are arising, how can we accommodate them? And pivotal to all this are demonstrations. Demonstrations is where we'll be testing the various options in various contexts for the provision of flexibility across Europe. That's why we've set up 7 different demonstrations, which are very complementary. I invite you again to check them out. Very, very interesting work that's being drafted, that's already been concluded in some of the cases. The thing is, I think it's relevant for us to say that they are highly complementary. So some will look at they'll look at various types of scarcities at different levels, at different voltage levels, and then different challenges that are being addressed across Europe in these 7 demos. Specifically, and let's now head straight to the Portuguese case. We've tested 2 distinct concepts in 2 different demonstrations. One is the virtual power plant in the world of VPPs, the world of aggregation, where we're trying to attain and use flexibility from the aggregation of different generation technologies. Really, the idea that we set up is the joint operation and dispatch of variable renewables, 2 wind farms here in Portugal, and a large dispatchable unit, a variable speed pump storage hydro, a large one, and to demonstrate what technical and economic benefits can come from managing these 2 assets under one single system, under one single hood, so to speak, which is this virtual power plant. And so this portfolio can be managed as we will show ahead. For this, the consortium partners that we've gathered under this work package are ourselves, EDP New, so Siemens Energy, EDP Produção as the hydro plant operator and owner, UNS, EDP's trading unit, EDP Renewables, our renewable generation unit operator. And then on the flexibility hub, we're doing a different thing. We're trying to collect and use in the best way possible and create conditions for flexibility from DSO connected assets to be used. So we're talking about the provision of flexibility in the forms of active and reactive power in different settings from assets that are connected to the DSO grid. We're talking about RES plants, so storage. And one of the things we're testing is a technical validation of the market flexibility that can be activated by the system operator. For this, we have our colleagues from Inestec, Rede, Portugal's largest DSO, part of EDP Group as well, obviously. Ourselves new and also EDP Renováveis, because there's assets here that belong to EDP Renováveis. We won't go into detail the Flexibility Hub, but we do have some plans to host an R&D session in the future dedicated to this second demonstration. Okay, make sure to follow us, follow the project. Again, we're in the final stretch of the project. I mean, now the great parts are coming, results are coming in, and conclusions are coming in. So we have a lot of work developed already. Stay tuned for more webinars that we're planning to host early next year. Now, okay, this concludes my overview of the project, and I want to pass the word over to Michael. Just to provide you some words, Michael Wenzel works at Siemens Energy. He has a master's degree in applied computer science in 2006. He joined Siemens in 2007 as an engineer for power plant automation. And from 2010 to 2015, he worked on implementation of plant and fleet management systems. And since 2016, he's been the technical project manager in Siemens Gas and Power Digitalization Group in Erlangen, Germany. And he's been working with us in Project EU-SysFlex from very, very early stages since 2018. And he's been one of our key people at Siemens Energy. So, Michael, welcome. And the floor is yours.
Thanks, Miguel. Thanks for the introduction and for having me here today. Yes, I wanted to give you a bit more a technical overview of what we've done with the VPP solution in the EU-SysFlex project. And yeah, just to pick up the overview of where Miguel just left us with what was the setup of the VPP that the components that we use in this EU-SysFlex virtual power plant. We started off with the vendor number 3 plant, as mentioned by Miguel, so a large-scale pumped hydro storage unit or a plant with 2 units that we form an essential part of the virtual power plant assets. The other 3 ones shown in the box were initially planned, but didn't make it to the demo due to several reasons. So just for the purpose of this presentation, we can just ignore them. Moving on to the renewable energy sources that we wanted to demonstrate the integration in the VPP with. That were the 2 wind farms, as you can see here, Alto Cutada and Falbera, 2 large-scale wind farms. And now, what do we need to get them combined into a virtual power plant? There's obviously some external data that we would need to consider in the virtual power plant control. That is, if we have wind renewable energy sources, obviously we need to know some sort of weather forecast to be able to come up with a prediction of what the power output is going to look like in the forecasting horizon of a few hours to a few days. And then we want to be able to deal with the entire setup, meaning vendor number 3 and the 2 wind farms, and bidding these into the energy markets as well as ancillary and providing ancillary service. So the flexibility here with these pumped storage plant and the renewable energy sources is going to be provided by a joint operation and dispatch of these assets. The goal was to demonstrate technical but also economical benefit of this portfolio management, you can call it, of these generating assets. As implicit result of that is that we're actually allowing renewable energy sources in form of wind to participate in reserve markets. The focus was just on the AFRR market as part of the demo. And we used some offline scenarios also to show the potential of replicating this approach in different scenarios and different setups, considering other assets. So now, when we think of our virtual power plant, what sort of tools, what sort of technology do we need to be able to effectively control and operate a virtual power plant? And the way we tackled this was that we decided we need a twofold approach. We need one on the one side, and that is shown on the left-hand side on this slide. We need some sort of optimization and forecasting tool that we called the virtual power plant core, providing core functionality, with a clear focus on really forecasting the available power of renewable energy sources, forecasting energy market prices, and based on these inputs and obviously a few more, coming up with optimized market bids that in the end consider the entire virtual power plant to be placed in the market. And once we know what the commitments are, then optimize dispatch schedule consisting of set points for each asset is being generated. And this process is constantly repeated and then communicated back over to the right-hand side of this slide, which is the VPP controller, and that forms our control interface to the dispatch unit. So that means a component that really sits very close at the automation level, and this is being able to, in near real time, communicate with the dispatch, or let's say in our example, especially with the Renewables 3, by sending set points, adjusted set points over, but also collecting status information, like what is the actual current output, how do we deviate with the set point from actual output, is there any other status information that we need to consider, some unplanned short-term unavailability, for example. So all these data is collected by the controller and then fed feedback into the core and to be considered into the next optimization run. So really a twofold setup here with the core running as a cloud service actually, and the controller running on a dedicated server, very close to the automation level of EDP. Yeah, the next slide really shows you the very technical aspect of integrating these things together. So on the top right side, you see the VPP core as a cloud service. This component is communicating to an endpoint, let's say, in the EDP corporate network for collecting weather forecast or weather data and market data. So there was an integration required here between these two components. And the other arm of the VPP core is kind of reaching out to the controller, to the VPP controller installed at the DMZ kind of network zone within EDP's control network. And from there, via a dedicated protocol, power dispatch set points are distributed to EDP's automation systems. And on the other hand, as I said, we use this to collect status information from the controlled assets. Yes, thanks. Right, now when we now look at the online demonstration, so what do we want to do with the online demonstration? And that was really the focus was to show the technical feasibility of the approach chosen with having a cloud service and a controller. And also, it was not just a software development project and effort here to get this done. There was also a lot of integration work be done in the end, especially on integrating service on the EDP side to kind of visualize market bid data that is being calculated by the VPP core, as well as on the EDP Portugal automation level, really integrating and permissioning a link to be able to send set points on with the Fieldbus protocol. And all this effort finally paid off on this particular day in May, when we were had the ability to go live with this entire setup for a window of, I believe it's been 2 hours, where we actually had an autonomous end-to-end control of the demo site, or demo VPP, consisting of the window number 3 plant and the wind farms. Obviously, a few restrictions we had. Some things were not fully autonomous, especially the market participation, as this is still a theoretical thing we were trying to prove. But in the end, there was a very successful demonstration and showed that the technical concept is very much applicable for what we were trying to achieve. Yes, and just to give you sort of a visual insight and what we were looking at during the online demo, yeah, you can see different screens from the different systems. The VPP core and controller systems on the left-hand side, monitoring the dispatch, the set point implementation, and on the right-hand side you can see how market bid suggestion and dispatch schedule were implemented and visualized at the UNJ, so the corporate network, to be reviewed, and on the automation layer at EDP Portugal, we could see that the VPP has been set up as an own balancing area, and to monitor the deviation from the set points also. So when we look at what we also did during the project was, beside the online demonstration, was an offline demo, which is basically a simulation of the performance over one entire year, the 365 days, with the use of the VPP core. That means we picked a year in the past where we had all data available in terms of market clearing prices and weather data and so on and so forth, and ran a couple of scenarios that I'm just going to explain maybe 3 of them to you, that are also shown in the table on the lower left part. You don't need to pay too much attention to the actual numbers there. It's just that more to give you that was for us to give us an indication of what is the potential in terms of revenue and in terms of imbalances that we see with different approaches. And the first scenario covered the individual run of A, the vendor number 3 plant by itself, and B, the wind farms by itself. And then that was sort of our baseline scenario. And then the second scenario with this offline demonstration simulated the operation of these components within the VPP concept, and we could already see that there's a significant reduce in the imbalances that we occur, and especially in the penalties in the monetary side. And one of the other scenarios we also considered was looking at, okay, what if we had perfect forecast available, looking at perfect weather forecast and perfect market price forecast also. And this, again, obviously showed us another gap and potential for improvement, that forecast is a key factor for the economic benefit of operating in a VPP setup. And all this data has been part of one of the deliverable reports. We use Tableau for some nice visualization. And then, yeah, it's, as I said, available in one of the deliverables. Yes, and that brings me to some key findings. So that this is not a comprehensive or complete list, and actually some of these things we already knew before we ran the demos, and especially the offline simulations. But these offline scenarios just manifested some of these points that we saw. So that means when we look at the first point, the pooling of volatile producers or renewable energy sources, reduce the relative forecasting errors. That means if I just have one wind farm, and forecast error will have a huge impact. If I have multiple, the forecast error is kind of potentially swiping each other out a bit, at least. Another finding was that obviously pooling of producers and consumers has a direct impact on the reducing of effects from uncertainty in market price forecast. That means everything I don't have to trade over energy and reserve markets helps in this regard. Another important factor is obviously that energy storages will be a huge lever in the future to shift power production and consumption, also allowing to do price arbitrage and handle deviations from forecasts. And the last point, actually addressing one thing I already mentioned, that more accurate forecasts of market prices and other inputs, there is a huge lever here for improving the overall accuracy, and with that potentially in the end any revenue. And of course, market bidding strategies is something that is where we just had a basic, let's say, setup that we see can be tuned, but requires very good knowledge of a local market.
Okay.
And with that, I think I'm done with the presentation. Back to you, Miguel. Thanks.
Thank you. Thanks very much, Michael. Okay, so I mean, now as promised, we're going to go to our roundtable, and I'm going to ask now to join us my good colleagues Miguel Patena and Bert Martins. A quick introduction of them, in case you don't know them. Miguel is the director of H2 and innovation at EDP Produção. He's responsible also for the hydrogen engineering competence center at EDP. He has extensive experience in the sector, more than 30 years of experience. More specifically, over the last 7 years, he has coordinated several innovation projects in the areas of clean technology and the technologies in decarbonization, and specifically around the areas of floating PV plants and hybridization of hydroelectric plants, flexibility of hydro assets and storage applications with large-scale batteries for isolated electrical systems and hybrid plants. He's 56. He has a master's in power systems from Instituto Superior Técnico in Lisbon, and he also has a business management directives program and also postgraduate degree in sustainable energy markets. Bert is the current director for electricity markets at EDP, at UNS, our EDP's trading unit. He's 55. He completed his degree in the Porto University a few years ago, after which he joined the National Dispatch for the Electrical System. And after some years, he moved to the System Optimization and Commercial Operations Division. He then followed up to after the liberalization process of the energy sector, he left to work on the team responsible for the creation of the Energy Markets Division. As of today, working in the Electricity Markets Division, Berto is responsible for the management of the generation portfolios in the Iberian markets, including real-time optimization, short, medium-term planning, outages coordination, bidding strategies on both energy and services markets in the Iberian Peninsula, in coordination, obviously, with the system operators. Thank you all. Welcome to both of you. Thanks for joining us. I mean, I wanted to have the discussion around the benefits of the virtual power plant, the possible risks, the benefits and possibilities of this concept. And I mean, one of the ways we looked at this virtual power plant, and I think Michael has expressed this very well, is that we're looking at it as a portfolio management tool that it is, as a way to integrate more renewables in the system, by, in a way, providing RES plants with an option to participate in the market. This obviously in a scenario where these RES renewables are going to the market with no feed-in tariffs, of course. Maybe my first question is to Bert and to Miguel as well. Do you see this as a viable option? Do you see the VPP as a viable option to integrate more renewables? Because there are alternatives. I wanted to hear from you what do you see, how do you see this concept in this scope?
Berto first, or
you can start, Miguel. You can start.
Go ahead, Miguel.
Before answering that question is perhaps why we did this, why we get involved in this project. This SysFlex, and this, I think it's a new benchmark, or is a project that was very important within the EDP framework, and also the context outside EDP, because it was designed where there was no regulatory framework for this type of combination of several sources of energy in the same connection point. And I mean this in particular because, as we know, we are investing a lot on the hybridization of our portfolio. Hybridization means connecting several energy sources or different energy sources in the same connection point with a limitation of the power output. So we cannot increase the power that is contracted, but combining wind, solar, and hydro, and whatever. So this virtual power plant concept is of most importance to manage the combination of these assets. And not only on the point of view, a technical point of view, we have to combine to see what is the technical, I call it technical energy source that has to fulfill a certain demand, but also on the economical point of view, which has to balance and to have a decision process, a decision algorithm that decides what is the technology that has to satisfy a certain bid, a certain price in a certain moment, without surpassing not only the demand but also the technical restraints that have in a point. So the answer is yes. The virtual power plant algorithms, or the virtual power plant combination concept, is a must in the actual evolution of the portfolio that we have in Portugal, and of course the portfolio that we're going to have in Europe to manage this renewable integration. And then perhaps I'll pass to Berto, and then we can.
Yeah, I can add something also on this. So obviously, as Miguel Patena was saying, the framework that we have in Portugal is not exactly the most adequate one for this VPP concept, and this was obviously a very extremely important project to demonstrate that in fact that the viability is achieved. but also looking for what Michael explained about the forecast algorithms and the optimization of biddings and the cross-market product, let's say, because it was looking also for the AFRR, so the ancillary services approach. And this is in fact a tool that it's very important for foster high renewable penetration, because it can be obviously used within smaller portfolios with aggregators or with small retail companies that can somehow update their VPP assets according to the technologies that are present. But the main thing, as Miguel Patena was explaining, is in fact to demonstrate the possibility to manage a completely different set of assets, being on a hybrid plant or being geographically distant, but it can be in fact managed accordingly to these optimization algorithms that Siemens Energy implemented that can optimize the assets, bringing benefits and maximizing the welfare for the customer at the end.
Thank you. Thanks, Bert. I think the question comes to mind now is because we're talking about the aggregation of different assets, and what we've tested was wind and hydro. But indeed, at one point we had a plan to use this for the hybrid plant in Alqueva, which includes not only hydro, but also floating PV, also electrochemical storage, and we'll soon add other plants, wind and solar, I believe. But I wanted to ask Michael. We've always discussed the VPP as being adaptable, easily adaptable to these various different kinds of assets, right? Can you please elaborate a bit on, how do we do it? What is the scale of change that needs to happen for us to adapt and to integrate different types of assets in our VPP? Can you please comment on? Yeah.
We approached this the setup of the tool and the development in a way that we wanted to be agnostic of any type of energy or generating asset, let's say. So that means we cover the basic concept of that a physical model is being implemented and is kind of a digital representation of the physical asset on site or in the field. That means if there's for us not much of the, or it's just an easy way to integrate another type of energy source. When, for example, when we talk about solar, we would just need to add another component type, model it with its respective parameters, and connect it to the right forecasts, and include it in the constraints and equations that in the end solve the optimization problem. So we're really flexible here, and in fact that was for me always very important to have that ability. Mm-hmm. And so all the underlying structures are already there, and we could start immediately.
Mm-hmm. Yeah, no barriers, right, Michael, as we were discussing.
Yeah.
One of the things that comes to mind is flexibility coming from the demand side. So this flexibility that comes from customers. So demand side management schemes. Does this make sense that we integrate? Would this make sense? Let's now for a second forget about the regulatory barriers, and we'll discuss that in a second. But maybe I'd ask Bert. Does this make sense?
Of course it makes. So it's another asset. It's another kind of asset. So as Michael was saying, in theory, the algorithm is agnostic to technologies. So it should be, in theory, possible to adjust a set of demands, of flexible demands that are managed through an aggregator, and in which one of the set points will go exactly to the AGC of that aggregator that afterwards will split from the different assets belonging to that demand flexibility to the aggregated demand flexibility, switching on or off the set of assets that will be optimal and possible, of course, in every moment within the required needs. So if the core is telling the system that it's necessary to increase generation, it will be exactly the same as decreasing the demand. So it will be an asset manageable and optimizable together with the rest of the assets belonging to the specific VPP. So this is obviously and for sure expandable for an aggregation of demands, of flexible demands that can be optimized at the end of the day.
Yeah, and as Michael was saying in his presentation, I mean, pooling of these volatile resources does, increase the flexibility, and does reduce, uncertainty for a system operator, I presume, and for the VPP operator himself. And I think, now going to the topic of the regulatory context, I was going to, things are changing, things are moving here in Portugal. There's a new, this context is changing. Just recently, there was a new decree of law approved, in which we, already expands on the role of flexibility, aggregation. Can you comment on Berto, and maybe Miguel Patena as well, because this is a bit specific for Portugal. Do you think this opens the door for the VPP for us to in the future, in the very near future, to have our own virtual power plant implemented in full swing here in Portugal?
Well, if I can start now, Miguel, if you don't mind. So I'm sure that it was not related to the project and to the VPP demonstration, but very recently we had the good news from the Portuguese NRA that the market will evolve in the next year, 2022, with a much more European approach or European context, let's say, considering the aggregation of imbalances, of individual imbalances by the portfolio of each individual company, which in a way, it expands the VPP context to all the player portfolio, let's say, which is able to provide those balancing services. So it will, from one point of view, to decrease the importance or the relevance of a VPP within our own internal portfolio, because we will be able to manage our assets, and we have a very flexible portfolio in Portugal, as most of you know. So for that point of view, the importance will decrease. Nevertheless, and as I mentioned previously, this is a very useful tool to make this kind of optimization, and looking for what we just said about the aggregation, about the demands, batteries, and smaller portfolios. It will be possible to implement this not only in Portugal, but obviously in every European country, as Michael said. So looking for specific particularities of each market, namely for the kind of ancillary services that might be used and the forecasts that have to be tuned to each individual market, of course. So the tools will have to be adjusted. It's not something that you can take off the shelf and use directly in a specific market, but it will be for sure a software that will provide flexibility for smaller portfolios, which cannot have the same degree of flexibility as the big utilities have for now. Is this looking only for the VPP context? Of course, as you mentioned, for the other parts of the demonstration, like the flexibility hub, it will be obviously also very important to allow those local flexibilities to participate in the markets and to have the big degree of access to these ancillary services markets.
Perhaps I just only to add that, because it's now, if this seems obvious now, is because it was a good decision 5 years ago. So that is very, very relevant here, because this regulation does not change from one day to another. And then what we did within this project also internally, at least in the Portuguese context, was also to promote and to demonstrate ahead the importance of regulatory changes to address this type of aggregation of portfolio. And for instance, a very good example is the Alqueva floating PV, which is in my background. that was not foreseen when we started as not allowed to be a hybrid project, was not there was no law that foreseen that. And also when we started and addressed ERS, for a simple reason, if we could aggregate in the same balancing area the floating PV and the hydro, because it was not possible. And then of course the answer was, it makes sense, it's the same connection point, it makes sense that these two different energy sources could be connected in the same balancing area. And so this goes step by step, and of course to an obvious, for us, an obvious arrangement that is getting closer to other practices in Europe, as Bert was saying. And for bringing also the subject for the aggregation of demand side, what I'd like to see in this, and so that's why I've started in this SysFlex project, is an holistic perspective that you mentioned, an overall virtual power plant that you can have an optimum decision, economical and technical point of view of all assets that contributes to the energy, satisfying an energy demand, which is demand side, storage or distributed energy sourcing, or centralized energy sourcing. And that is the overall idea, that we can get something that rules and optimizes on economical point of view what are the best proposals to satisfy a demand of energy. Could be this last thing, or could be the reducing load on a factory, or can be increasing load on a hydro plant or whatsoever. So that is for me the biggest challenge that we have in the future.
Yeah, and at the end of the day, it's indeed an optimization problem, as you were saying, and I think that's a key component here that we've touched on very briefly. But I wanted to hear Michael on the topic of forecasting. Forecasting is a key component of the concept, of the VPP concept, because we're using forecast not only for weather, wind, for the water inflow in the case of our VPP, solar, if we had PV. We're also doing it forecasting for energy market prices. I wanted to hear from Michael, I mean, how sensitive to forecasts are our results, and how can we improve or is there room for improvement in the models used, and in how can this be? I mean, I think you've said it. One of your final topics was that better forecasting is a lever, right?
Yes.
So can you please elaborate a bit on that?
Absolutely. I mean, there's always room for improvement for forecasts, and I mean, if every one of us had a perfect forecast, we would probably not be here. But there's two things. One is I mean, technical improvement. I mean, using statistical methods, using state-of-the-art machine learning technologies to identify patterns, train models on all the existing data, and taking into account other features that can feed a model to come up with even better forecasts. And then it's actually what we're already trying in parallel to use different type of algorithms than we used for this demo now, and see where we could benchmark or can get a better benchmark. And the other thing is obviously it's what we've seen also in the project, experience and knowledge and market knowledge. And this is a component that is not to underestimate that there's always a factor that you cannot really calculate, and that there's something that just comes with an experienced trader has probably some inside knowledge that you cannot cope with just technology. So I see it as a combination of both.
Okay.
Yeah, Miguel, if I can add
Sure.
something on this. I think, in fact, this is for the tool itself one of the crucial things to improve, because as Michael explained, on that day in May, we demonstrate that the control is perfectly optimal, and we sent set points for the hydro asset to compensate the imbalances generated by the wind technologies. But it's not only the question of improving the forecast of the current mechanisms, but also to consider what we call the cross-market optimization, because there is obviously much more than AFRR to consider. Even the volatility of intraday markets is increasing a lot in the last, 1 or 2 years. We sometimes start 1 hour negotiation, prices going up, and end the hour negotiation coming down. So if it's something that can be forecasted, it's obviously something that can be used not only for the optimization of the assets, because at the end of the day, optimization of the assets will lead to lowering costs for the end consumer. I don't have any doubt that it's not only a question of the income of the assets by itself. It will be, at the end of the day, minimizing the costs of the system as a whole. So the end objective will be to get the lowest cost possible. So maximizing, as I said previously, the European welfare on the markets in which this kind of softwares will be used. So it will be very important, in my point of view, to improve as possible, as technology allows, to improve the quality of the forecast used, not only for wind and solar, but also for the market variables at the end of the day.
Mm-hmm. Okay, thanks both for. I mean, I think we need to to end it with a question about the future. But before that, and I do have a question about the future of the concept. But before that, we do have a question from the audience, which I want to pose to you to see if, who picks it up. The question is if from sorry, let me say Jade Nishi. Not sure if I'm saying the name right, but the question is, how do you see the opportunities to implant or sell a VPP solution in a metaverse context? Could it be possible? I'm not sure who. I'm not entirely sure who. Does someone want to pick up this question, or should we ask for clarification?
If the question is if the virtual power plant can be a service is contracted by others, yes. So it's like an aggregation with some intelligence behind it. So it's a tool that can be used by aggregators. So it's a sellable product. And that's it. The complexity depends on the number of assets that has to manage and the type of decision that has to be done. But this, of course, is a product. And this is the spirit of the SysFlex, is that demonstrate a tool that can be used elsewhere, not in Portugal. It's demonstrated in Portugal, but is a tool that is, as Michael said, is a universal tool that can be used elsewhere.
Okay, thanks.
I'm not
Miguel.
sure if I addressed the metaverse context, but as far as I know.
Well, metaverse, I assume that it's virtually saying, let's say, but VPP, it starts by virtual power plant. So by itself is already in the metaverse context, let's say. But the point is that we have to keep in mind that electricity is a physical asset at the end of the day. It has to be delivered physically. The penalties are real, are not virtual. So we have to manage the assets and the software much more in the physical world rather than in the metaverse context. But nevertheless, as Miguel was explaining, it can be used in several different. Okay.
Thanks. But on that same note, I mean, and to wrap it up, I think we need to just discuss a bit, 1 or 2 minutes about the future of the concept of the VPP. One of the things we've addressed already is expanding to different kinds of assets, because, I mean, there's no reason why we shouldn't do it. There's no reason why we're not doing it for the context of this, of Project EU-SysFlex for the Portuguese virtual power plant. We did it with a few assets, but there's no reason why we can expand to other assets. Another one being improvement of the forecasting models. But I'm also thinking a bit beyond that. I mean, what's the future for this? And I'm thinking of things like in a context, and you've all mentioned the fact that we're heading towards, I mean, markets and namely ancillary services market expanding way beyond national borders, can things like cross-border VPPs make sense? I reckon the answer is yes, but I want to hear from you.
Well, I'm getting back exactly for the previous comment about the physical world. Don't forget that for cross-border VPPs, you have to take into account the interconnection capacity between the countries. And that is something that for now, it is not monitored in real time by the owners of the assets, and even the TSOs tend to not to publish that data in real time, so the capacity that is used in real time. So I see that a little bit more
limits.
difficult. Yeah, with some limits, at least for now. Some TSOs in Europe are much more transparent. Hopefully none one from REN is here hearing me, but
Yes.
okay, but on this kind of topics, I can address for example, the Dutch TSO is publishing in real time the imbalance of the system, which allows the national participants in the market to self-balance the system, not by itself. So they can somehow foster their own imbalance if they are helping the system, because they will get a reward on that. With this kind of approach, this proactive approach, at the end of the day, the amount of ancillary services that the Dutch TSO will need will be lower, and the costs for the system will also be lower. And this is something that is, as I call, transparency. So the kind of data that allows participants to optimize their own portfolios, but at the same time to help the system and to decrease the costs of solving the problems. Okay, that's why I was talking about transparency. So the interconnection can be in the future also transmitted to allow the level of cross-border participation in this kind of services, because in real time, the platforms have to get access to that to know if it's possible or not to trade AFRR or MFRR within countries. So it's something that the TSOs have, but they are not using that kind of information in real time to give to the players, to foster this kind of trades to help the system also. It's not only about maximizing the incomes, it's obviously helping the system too at the same time. See, if I have an excess of energy, I can somehow foster my imbalance because I know that I'm helping the system. So we both gain. It's a win-win situation. So it's not a question of using that information to put the system at risk or to decrease the efficiency of the overall process. It's much more to help everything to be much more optimized.
Yes, and the system has to evolve in the future in the European market as an old system where the transparency that Berto mentioned it's very important. If you have the data available, then it's only to create a rule that forwards or pushes the decision towards a benefit for the overall system. The less transparent you are, the less optimized you can be. And so I think there's a crucial point here. I would prefer that we had all data available, and then on top of that, then you define mechanisms that, of course, complies with transparency or complies with the competition, fair competition of all. But it's not restraining the access to the information from below. It's the opposite, leaving the information available to everybody and then defining rules that fosters competition between participants. And then, as Berto says, it is a what I call it a positive cycle that you create to decrease, to enhance competition and decrease prices on the benefit for all. I think this is a very important lesson, and all the what you call it the step that we did on SysFlex was always towards this type of way of being in the system. Yes, provide information, go onto the flexibility, use the system as an overall system that you can use, and then please define the rules that allows competition to happen. not restriction. For instance, balancing areas, portfolio management, and all that Berto also mentioned is getting rid of restrictions that does not allow a market optimization.
Okay. Thank you. Thanks very much. Very insightful discussion. I think we have or had a raised hand. I'm being told. I'm not for Antonio. Antonio. Yeah, Antonio, do you want to?
There's a question there, I think, on the chat.
Yes. May I?
Yes, you may, of course.
I have a question because what you showed was mostly a virtual power plant that was composed of a dam and wind farms. But are you planning or have you worked over virtual power plants that are comprised, let's say, of thousands of electrical vehicles or residential PV and storage? Because probably that will allow a very interesting business model. When you start using the batteries of cars that are parked every day without being used, or even residential PV that most of the time is not used to its fullest. Is that in the pipeline?
Yeah, maybe before I give the word to Bert or to Miguel, my first answer is that actually there's another demonstration, one of the demonstrations in EU-SysFlex in Finland, coordinated by Helen, is an aggregation platform for assets connected at the low voltage level. So we're talking about small PV, rooftop PV, batteries, residential, and also installed in some offices, and electrical vehicles to be used for both, I think, ancillary services and also to compensate some DSO reactive power needs. And so that's definitely in the pipeline. That will definitely feature in the, from the project's perspective, is my answer now. That will definitely be featured in the flexibility roadmap that will define as the end game, as I said, of project EU-SysFlex. And so I also invite you to check that out. I think very interesting work being done by colleagues at Helen. I'm not sure if my colleagues want to complement.
Excuse me, Miguel. Probably Michael will be the best one to address that, because it's probably on the code point of view, let's say. But in theory, as we mentioned in the beginning, this tool will be technologically agnostic. So it will be definitely possible to send the set point from the tool to the different assets that are being managed, being a large utility or being distributed generation, or even customers within the aggregation. So in theory, it's possibly used. But Michael, from the code point of view, can you give some extra information on that?
Yeah, so from the capabilities of the tool, I think this is, as you said, this is very much possible because it's in the end just another component, another layer that needs to be represented and implemented. So yes, the tool is, with enhancement and some extra work, would be able to do that. From a Siemens Energy point of view, so most of our customers are usually utilities running large-scale generating assets. So the focus, that is our primary focus to see to serve their needs. So looking at residential installations and smaller batteries is yet, let's say, not a primary focus, but definitely something that we'll have in our minds, and we'll keep considering it.
Yes, I think Antonio mentioned a point that I've tried to address before, is that it's important that when we build all these systems, we don't think on only one tool that solves all problems, but a set of tools that solve intermediate problems, then converge to the optimal solution. So you can merge distributed or aggregation of distributed assets with different geographies, and then with I call it centralized assets, also big utility scale assets. That at the end there's I call it an optimum solution for the system in an economical point of view. And that the objective is that you can, in the future, converge and have I call it like a not a big brother, but something that manages or overlooks all these assets playing towards an optimal solution of the system, in an economical point of view, in a market point of view, and the welfare of the system. That is the key objective. So, but we have to start building the small dots, and the small aggregators and the small clusters that overall combines in the final solution.
Okay. Okay, I think this concludes our discussion and so our session as well. Thanks very much. I think this was a great discussion, very insightful roundtable, and thanks again for the audience for your questions. I think this concludes. I'm not sure if Monica wants to conclude with some words, but I think this concludes this year's session. I think we finished on a very high note. So thank you everybody, especially thanks to my colleagues participating in the session. Thank you.
Thank you.
Thank you, Miguel. I just wanted to thank to all of you, especially to our guests for accepting the invite and for being here with us, sharing their knowledge and time. I think it was a very interesting session, a very rich session. Also want to thank to you, Miguel, and your team to help us organizing the webinar, and also to the attendees, of course, for being here, supporting us in every webinar that we organize. And this was a great year, and every webinar that we organize, we are increasing the number of attendees, which is a good feedback. So we will keep doing the same work for next year. And in January, we will stop, but on February, we will start again with these webinars. So stay tuned with our social media, and then you can see when is the next webinar and what is the topic that we are going to focus. So thank you very much, and see you on February. Bye-bye. Thank you.
Thank you. Goodbye.
Bye. Thank you.
Bye. See you.
Bye. See you.